Hi everyone, I'm Charles Dixon and I'm a member of the SDK team at Couchbase. In this session, we're going to take a look at Couchbase Shell, which is a modern way of interacting with Couchbase on the command line. We're going to cover a bit about what Couchbase Shell is. You're going to hear a lot about new shell, so we'll cover a bit about what that is. Most of the session will be a demo, and then we're going to look at what the future looks like for Couchbase Shell. So to begin with, what is Couchbase Shell? The general idea behind Couchbase Shell is a single command line application for all your team. So that's kind of in day-to-day usage of interacting with Couchbase. So things like managing your users, your buckets, importing fake data for tests and general development, and then things like cluster health checks, including things like seeing the state of all your nickel indexes and things like that. So we're built on something called new shell, which we'll cover in just a moment. We're a single binary, which is available cross-platform, and it's written entirely in Rust. If you've previously used Couchbase Shell, then you might know that we were built on top of the Couchbase Rust SDK. Well, we've moved away from that for various reasons. And what that means is that whereas previously you needed some dependencies such as OpenSSL installed, you don't need that anymore. Now it's just as simple as download it and run, and that's it. We have support for not only running standalone commands and running in the shell, but scripting so that you can have reusable scripts. And a key thing that we really wanted to have is this ability to run a single command against multiple clusters at a time. And that includes being able to run against Couchbase Shell. So let's move on to what new shell is. The philosophy behind new shell is to take something that most people who have been working with the command line for a while are familiar with, which is pipes, and being able to use those to pipe single commands together, which you would expect coming from something like, say, Bash or PowerShell, and then bringing that into a more modern style of usage. So what do I mean by a modern style? In new shell, everything is structured data. Well, all data is structured data. And what that means is that data is in things like lists or a table. So the example you can see on the left there would be a table. And what this means is that your data, when you pipe from one command to another, the data remains structured, which means you can easily filter, transform, export. You can do all sorts of manipulations really easily at any step in your pipeline. So on the left there, we can see running the ls command in the Couchbase Shell repository, which just shows all of the files, one row per file in a table. On the right, we run that ls command. We're going to pipe it into a sort by name. We're going to take the first 5 rows, and then we're just going to select the name column. And that's what the output looks like. Let's move on to a slightly more involved example. Here we're running git log with a custom format where we're separating the items in the log by a double hash. And git log will output one commit per line, and it's just a load of strings. So we then pipe that into the new shell lines command, which creates a table, and for each line in that git log output, it creates a row. So we then pipe that into the split column, which is going to see where those double hashes are and split on those double hashes so that we then have rows and columns. We then pipe that into a histogram, sort it by the merger column, reverse it, and take the top 10. And then we get an output of a histogram that looks something like this, where we can see the name of the committer and how many commits they've got. And this is running against, I think, the old Couchbase Java SDK. as well as being able to run the script commands standalone. As I mentioned before, there's support for scripting. So here we've got a really simple script, which is called show big files. And within it, it's called show size. Within it, there's a function called show big files, which takes two parameters, and it just takes the minimum size of the file and a column to sort by. We alias this pipeline, which is to list all the files where the size is greater than the min size, and then we output the result of this alias, and we sort it by the sort by. And then in this script, all we do is we call this function with a minimum size of 10 kilobyte and a sort environment variable. And that looks like this. We're going to sort by the size column, and then we have a table which shows us all of the files in the Couchbase Shell directory, which are bigger than 10 kilobytes, and they're sorted by size. If you want to learn more about GNU Shell, you can check out their website, which has lots of information available. You can also check them out on GitHub and Discord. They're really friendly and really responsive, so get involved. It's all good. I've been using GNU Shell for over a year now as my daily shell, and it's pretty great. So I do encourage checking it out. And with that, we'll move on to the demo. So the first thing you see when you start Couchbase Shell is this custom prompt. And what we've got here is we've got the username that we'll be using to authenticate when we send commands. We've got the name of the cluster and the name of the bucket that we're going to be running against. So let's take a quick look at some at the resources we've got available right now. If we run the clusters command, we can see we've got 3 clusters that are registered against the shell: My Cloud cluster, Dev Remote, and Dev Local. You can see Dev Local is currently set to active, and that means that by default, that is the cluster that commands will be run against. You can also see My Cloud cluster has this My Cloud org cloud organization registered. So in Couchbase Shell terms, a cloud organization is basically a cloud API key for the Couchbase Cloud public API. And what that means is that we can run commands like management style commands. So users create, buckets drop, that kind of thing. If we didn't register this with the cloud cluster, we could still run commands like query or key value or analytics. We just couldn't do any of the management style things, only document level operations. So let's have a look what else we currently have set default. So here we can see all of our currently default settings, and you'll notice, if you attended last year's session and have a good memory, that we've added support for collections. So our default scope is users and default collection is staff. So let's take a look at how we've generated these resources. If we look in the config file, we can see that we have registered 3 clusters. We've got the Dev Local, Dev Remote, and My Cloud cluster. And in the Dev Local, we've gone a bit verbose and added a load of extra timeouts. You don't need to set these. The shell will set sensible defaults. We've explicitly said TLS enabled is true. Once again, that is by default true anyway. And then we've also got some credentials. Now you'll notice on the My Cloud cluster, we don't have any credentials. Well, that's because we put them in a separate file called the credentials file. And the reasoning for this is that you can then put your config file into source control, and you won't be leaking your credentials to the outside world. You can keep your credentials file completely separate, and so no one can see all your stuff while it's in source control. You'll also note that we've got the cloud organization registered on this cluster, and all we have to put in the config file, because we've got the credentials in the credentials file, we just have to say, hey, I'm here, I exist, and that's about all we need to do. So let's take a look at our clusters again. We don't want to use the current dev local cluster. we will use a different cluster, dev.remote. So when we change to this cluster, you can see that the prompt has changed. We're now in the dev remote cluster, and it's changed to use the travel sample bucket because that's what we set as the default for that. If we run use, you can see that the scope and the collection have also changed. Well, if we wanted to change bucket, we could use bucket default, and then when we run commands, it would use the default bucket, but we don't particularly want to do that. We want to stick with the travel sample bucket. So let's move on to looking at what our clusters look like a bit. So if we run the nodes command, we can see all of the nodes that are currently in my dev remote cluster. We've got a bit of information about them, such as the services that are running, the version, some information about memory, a really high level status, and whether it's a cloud cluster. So most commands in Couchbase Shell support this clusters flag. And what this does is enables us to tell this command to use a different cluster to the default. And this flag also takes a regular expression, which means that we can run it against all of our clusters at once. So if we run nodes against all of our clusters, we can see that we've now got the dev local nodes and also the cloud nodes in here. Well, my cloud cluster nodes. And that's reflected in the cloud column. The output is slightly different for the cloud clusters because the cloud API returns us slightly different information. As well as running it for all of our clusters, we could just run it for the dev group and we'd get something that looks like that. So moving on from this, let's have a look at a high level health for our clusters. So we can run this health command, which runs a really quite high level set of checks. So we can see what the check is, what we expected the output to be, what the actual output was, and a remedy should one be needed. And as we can see on the dev local cluster, auto failover should be enabled. It isn't, and the suggestion is just to enable it. But what if we want to see a bit more information about, say, what our services are up to and make sure all the individual services are looking okay? What we can also see now is that I've typoed the flag, and New Shell is, well, it's clever enough to see this isn't a flag that actually exists, and it's told me this isn't going to work. So I can correct that and run the ping command, which, there we go. And then we can see that we've got all of the services on all of the clusters. We can see which node they're running on, what the service is, and the latency. So if one of these had timed out, we would see that in the state. Or if another error had happened, the state would be error, and we would see what the error was in the error column. So let's move on to some buckets management. We can see all of the buckets in our clusters, and we can see the type, some information such as the minimum durability level, RAM quotas, which is enabled, really high level status for the Couchbase Cloud one. But what we want to do is make a new bucket. If we run buckets create with help, we can see that there are 2 required parameters, name and RAM, and a few extra ones that we can use. But right now, all that we care about is just running with the minimum possible. So let's create this CB shell bucket on all of our clusters. Which might take a couple of seconds, just because my internet isn't that fast. And then if we run buckets get, we can see that we've now created this CB shell bucket on these clusters. And it's probably just taking a while to register with the cloud, which is why it's not showing up yet. But we don't actually care about this bucket anyway, so let's drop it and wait for that to complete. Then when we run the buckets command again, yeah, it's gone. And so we've managed to create a bucket across all of our clusters in a single command, which you could also use for something like onboarding new users and stuff like that. But let's move on to working with some data. let's get an airport. Yep, that's an error. So the key's not found. Well, that's probably because we're using the wrong collection. So if we look at this, we can see that actually we can specify collections that we should use. So let's run that command with the correct collection and correct scope. So here we're specifying that we're actually going to use the airport collection. And there we go, we actually can get the data. So now let's make some fake data and import it. Couchbase Shell uses the Terra templating engine for faking data. So when we have a look at this example template, we can see that we have individual templates, and these are functions that are pre-registered with the shell. Something else you will note here is that we have two fields at the top level, ID and content. When you run an upsert or something like that in Couchbase Shell, it expects two columns. It expects an ID column, which will be the document ID, and a content column, which will have all of the document content. As well as these functions, we can list all of the functions that we have available, and there's quite a few. So you can create some reasonably sensible data with it. So let's actually create some data. So here we can see that we've created 5 rows and it's in the format that we expect. If we just flatten that out, we can see what data it's actually given us, which looks reasonably sensible. And then if we actually want to upsert that, all we do is run it with a doc upsert. And there we go. Processed 5, as we can see, and then all 5 were successful. So what if we want to store some of this data? Let's make a test data directory and let's move into it. So now we're here. What we want to do is we want to generate some fake data and then save each document we've created into this directory as a JSON file. So we're going to create 50 documents. For each one, we're going to echo the content, and then we're going to save it as a file name, which will be user underscore the ID that we generated, and then .json. So let's run that. If we list the directory, we've got all of our documents. And then if we take a look at one of these, we can see it's actually been saved as proper JSON. This is because when we specified the file name, we specified it with the .json suffix, so the JSON file type, and New Shell is clever enough to have seen that and automatically saved it down as JSON for us. So if we want to then use this and upsert it, all we do is we list the directory, all the contents for each item. We're going to open it, and then we're just going to upsert it. And this is going to upsert each document individually, which is why we can see we have 50 result rows. If we wanted to do something similar, but as a CSV, we would use a similar command, save as CSV. And then if we have a look at what's in there, once again, New Shell has seen the file type and saved it as a proper CSV. And then if we want to work with this, it's slightly different to the JSON because it's all one file. So what we're going to do is open it, and then for each row, we're going to wrap that row into a content column, and then we're going to create an ID column with the ID from the content. So it'll look something like this, which is what we need. And then once again, if we want to upsert that, it's just doc upsert. And this time you'll see it's just a single row with all 50 because it's done it as a single command. So let's move on to looking at query. We can run a simple query where we're selecting everything from the travel sample bucket and the inventory scope and the hotel collection, where the country is the United Kingdom. We're going to flatten it out so we can see it, and then we're going to run this pivot command, which just makes it easier. If you've only got a single row, then it just pivots the table around so it's easier to see the contents. So what can we do with this? We can run this query, and then we can flatten it, and using our each wrap kind of approach that we saw just before, we can put all of those into a content we expect to do in an upsert. So say that we wanted to then upsert. So what we're going to do is we're going to run this query against our dev remote cluster. We're going to wrap up the content, and then we're going to upsert the result of that query into our dev local cluster. And there we go. We've upserted all 416 of these hotels into the hotel scope UK collection on the dev local cluster. So hopefully you can see some of the power of being able to run a query on one cluster and manipulate or transform the data however you want, and then save it into a different cluster. So you could do that with analytics as well, with search. You can use, if we take a look at the query top level, we can see that we have query indexes, so you can export all of your definitions, all of your query index definitions for one cluster, and upsert them into a different cluster. So you can just move your definitions really easily. So let's take a look at the cloud. So the use command supports this flag cloud. And if we run that, it tells us the cloud specific information. So our cloud organization, which we've already seen, the cloud, which is the name of the cloud instance that we'll be running against when we run cloud specific commands, and the project, which is where we'll create clusters and things like that. So let's have a look at what clusters are available on the cloud. We can run cloud clusters, and you'll note this is different from the output of what's registered with the shell. And this is all of the clusters that are in this cloud that we have active. And you'll note that we have this other cloud cluster, which we don't have registered. So let's take a quick look at that cluster. And here we can see that the status is ready. So let's use it. So in order to use this, we need to register it with the shell. And we do that with clusters registered. And we give it the name, the address of where this is, the username we're going to use, and the password, as well as the cloud organization that we want to use with it. So at this point, if you're not familiar with cloud, then when you create a Couchbase Cloud cluster, you have to register a couple of things with it. You have to create a database user, and you have to register an address with it to add an address to the allow list, which is a list of addresses that are actually allowed to access that cluster for security reasons. So when we've run this command, this cluster doesn't actually have this user or my address. So I can't actually use it at the moment. But if I now run my clusters command, we can see I've got this cluster locally now that I can use. It's registered, I can access it. So let's use it. So if I grab this and then run users, you're going to see there are no users because there's nothing registered. So let's register a user with this. And here we're going to register Charlie, as we did before. Well, we're not going to register, we're going to create a user Charlie. And it's going to have these permissions and the password that we registered the cluster under. So let's run that. And that's created our user. If we now run users, we can see it exists. We need to do something similar with addresses. There are none. So let's create one. I'm going to add my address to the cluster and hope that it hasn't changed. And then when we run addresses again, we can see that it's registered. And we can do this because we're using the cloud organization rather than accessing the cloud directly at the moment, which is what we will do when we run things like doc commands. So if we then run a doc upsert against this Couchbase Cloud bucket, which we don't have set as the default, so we need to tell the shell what bucket to use. Then we can see it succeeded, and if we then get that document, there we go, it worked. We've managed to register a new cluster that we didn't previously have and use it. So let's move back to our remote cluster and unregister the cloud cluster because we don't need it anymore. You can't unregister the active cluster, which is why we had to change first. Let's take a quick look at some scripting. So here I have an example script, and what this is going to do is list all the buckets, get the names of the buckets, which is we're going to assign it to a variable bucket's names, and then we've got this function ops per sec, which for each name in the bucket, it's going to get the basic stats by running the buckets config command, which is quite a low level command, which gets the bucket configuration file from the cluster. Then from that, we're going to get the basic stats column, and we're going to pull ops per second out. And the script just runs this and sorts it. So let's try this. First thing that we need to do is we need to run this command. We need to actually do some work so that there are some ops per second. So we're going to run that twice, then run our script, and there we go. We can see that we are doing some work. We can see the number of operations per second that are being run against that cluster. We got a whole load of other commands. There's loads to go up. So some of these are new shell commands, and some of them are Couchbase specific commands. And hopefully you've now seen enough here to want to get involved and give it a go. Let's go back to the slides. So what does the future look like for Couchbase Shell? Well, we actually want you to help us there. We want to know kind of what you want to see and what you'd really like to work with within the shell. We've got a few ideas, things like being able to rebalance from the shell, but we do want to know what you want, and we'd really like you to give us some feedback before we go to the 1.0 GA. If you could create bugs for us, that'd be great. If you want to provide feature requests, that'd be great. If you want to provide pull requests, that'd be really great. So you can find our website at couchbase.sh, and you can also find us on GitHub, where you can create issues with pull requests or bugs or feature requests, things like that. Hopefully I've given you enough to think about and to want to try the shell. Thank you for attending.